In this video, I'll be going over the 1.1, 1.4 guided notes, and we'll be talking about the distributive property and simplifying expressions. So the first thing that I want to discuss is the idea of simplifying something. And so we've already talked about the idea of solving something. When we were using order of operations last week, we were solving each algebraic expression. When we're solving something, we are finding an answer. So we're going to write that down. And that keyword there is answer. There's going to be like a single solution. So we'll end up with x equals a number. Or we'll just end up with a final answer, like a single number, a single solution. So when we're solving, that's probably what we're most used to. So for example, something as easy as 2 plus 2 equals 4. We have a single solution here. Simplifying is different. When we're simplifying, what we're doing is we're combining like terms. So that's the definition we're going to use. So we're combining, I'm going to put this in quotes, like terms. And what like terms means, and I have the definition down here actually, like terms means that they're terms that contain the same variables and corresponding exponents. So another way of saying this simply is that they have the same base. I'm going to write this small under here. Same base, same exponent. Kind of ran out of space there. I'll abbreviate. Same base, same exponent. So here is an example of simplifying. So if I have 2x plus 3y, we need to talk a little bit about terminology here. These numbers out in front are telling me how many x's and how many y's I have. So I have 2 x's. Think about something that starts with an x. I have 2 xylophones plus 3 y. I have 3 yams. I don't know. 2 xylophones plus 3 yams. Those are not like terms. Xylophones and yams are not the same thing. So I cannot actually combine this. This is as simplified as it is going to get. I can't do anything more. I can't solve. I don't know what x and y are. If I told you x equals this and y equals that, we could substitute and solve like we learned to do last week. But unless I give you that information, there's nothing more that can be done here. And so it's done, and that's okay. We need to recognize when things are simplified and when things can be simplified further. This one is fully simplified. There's nothing else I can do. But if I had something like 4x squared minus 2x squared, I have 4x squareds. This is where the idea of the exponent comes in. So I have 4x squareds, and I'm taking away 2x squareds. These have the same base and the same exponent. Notice if this was just an x, if I have 4x squared minus 2x, those are not like terms because they don't have the same exponent. But because this one is an x squared as well, they're like terms, and I can simplify it. So if I have 4x squareds, whatever those might be, and I'm taking away 2 of those x squareds, I end up with 2x squareds. You don't do anything with the base and the exponent, the x squareds. It's staying the same. We're changing the amount of them that we have because I had 4 and I'm taking away 2, so I end up with 2. So now this is fully simplified. I notice how this is different from a single answer. I don't have a single number. I still have a variable. This could still be solved, but until I know what x equals, I can't actually do anything else with this. So that is the difference between simplifying and solving. This week, we're going to deal more with simplifying expressions. So we already covered what like terms are, terms that contain the same variables, meaning the same base, and corresponding exponents. So we're going to practice simplifying each expression completely here. We have 3x plus 6x. We ask ourselves, are these like terms? Well, yes, I have an x and an x. I have 3 x's plus 6 more x's. And what do I get? I get 9x. You combine, those are called coefficients, the number out in front. Let's take a look at the next one. I have negative 6x plus 3x squared plus 10x squared. So notice I have a couple things going on here. I have the x things, and then I have the x squared things. I actually only have one x thing, so I can't combine it with anything else. It has no like terms. So what's going to happen is this is just going to drop down. But I can actually simplify or combine these. I have 3x squareds plus 10 more x squareds. I can put those together. So what I'm going to have is negative 6x, and then 3 plus 10 is plus 13x squared. So that is the final answer there. Let's take a look at this last one. It does have a star by it for a reason. I have 10xy minus 4 times xy plus xy. Well, right now, we have 10xy minus 4 and then times xy plus xy. We're going to need to do something here. We actually can't combine or do anything yet because this 4 is currently separated from the xy plus xy. So actually, what we can do first, let's back up. I was going to do this a tricky way, but let's look inside. Let's remember order of operations. Let's look inside those parentheses and see if there's anything we can do. So I have xy plus xy. So do these have the same variables? Yes, we have xy plus another xy. We don't see a number out in front, so anytime you don't see a number, you assume that it's 1. I have 1 xy plus 1 more xy plus another. So I can actually add those together. They're in the parentheses, so if we remember order of operations, we're going to drop everything else down. 10xy minus 4 times, I have 1 xy plus 1 xy. Well, how many do I have now? I have 2 xy. Well, now that I just have a single term on the inside here, I have 2 xy's, I actually can multiply here. I can multiply negative 4 times 2xy. And this might be a new idea for you, but what's going to happen is I have 10xy, and then I'm going to multiply the coefficients. Negative 4 times 2 gives me a negative 8. And then I just keep the variables, x, y. Well, as you can see here, now I have 10xy minus 8xy. These also have the same base, same exponent, xy, xy, so I can simplify this even further. 10 minus 8 is 2xy. So that one was obviously a lot more involved, and this is the type of, put a star there because this is the type of situation that we're going to deal with more today, is simplifying as far as we possibly can. We'll look at examples where you're just doing one step to simplify, but we'll also look at examples where you may be able to do many steps to simplify. All right, so we're going to revisit this situation that we took a look at a couple weeks ago. So do you remember the Burger Shack order from a couple weeks ago? We watched a video where a guy called into Burger Shack, and he said he was placing an order for a party, and then he just started listing off items: hamburger, Coke, fries, Coke, hamburger, hamburger, fries, fries, Coke, chicken nuggets, fries, fries, chicken nuggets, Coke. So we discussed a few different ways of organizing the order to be able to easily determine the total cost. And so now I'm actually providing you with the prices. I said we'd be revisiting this. So if these are the prices of the individual items, what would be the total cost of the order? I want you to think about that for a moment. So we talked about a couple different ways of organizing these items, and hopefully you jotted down some notes and came up with something on your own in those few moments. And I'm going to show you a way that we could think about writing this that takes into consideration the individual items, but also the idea of grouping them into meals, because we talked about both of those ideas. So an easy way, and a way that we would typically order at a restaurant, is not like this guy, but we would actually group into a meal. If you want a hamburger and fries and a Coke or soda, that would usually be grouped together as a meal. We might call that a hamburger meal. I'll call this HM, a hamburger meal. So what a hamburger meal equals what? It equals a hamburger plus fries plus, I'll do S for soda. Whoops, sometimes it does that. But in this order, there was also a chicken meal. So CM, and a chicken meal would equal chicken plus fries plus soda. So now that we know the values of each of these things, we can write a little equation or expression to help us find the total cost. And we can kind of use these grouping symbols to also show more information about how many meals were ordered. So I'm going to just go through and I'll kind of highlight. So we've got hamburger, Coke, fries. So that's one hamburger meal. I'm going to kind of keep a tally off to the side. So I've got one hamburger meal. Let's do it again. So I've got Coke, hamburger, fries. That's another hamburger meal. And then here I had hamburger, fries, Coke. That's another hamburger meal. And then no more hamburgers. So now I'm going to move on to chicken nuggets. I'll change color. Chicken nuggets, fries, Coke. There's a chicken meal. And then we have fries and chicken nuggets. So this is a little bit weird here. We have fries and nuggets, but there's no Coke there. So this one, I'll just put a note here. We have C plus F. There's no soda there. So we can use this information to write a nice little algebraic expression. How many hamburger meals do I have? Well, I have 3 hamburger meals, so I can write that like this. 3 times, and then what goes inside there is the hamburger plus fries plus soda. So I have hamburger plus fries plus soda. And then I'm adding on to that order. So those are my hamburger meals. My chicken meals, how many total chicken meals do I have? Well, 1. So I have 1 times chicken plus fries plus soda. And then finally, I just have a chicken plus fries left over. So here's our total is going to look like this. Now, this equation would work no matter what the prices are. We could just plug in the value of each of these things and it would give us our total. But they actually provided us with the cost of each ingredient, so then we could plug in those values and figure this out. But something I want to point out is that if this is what we were working with, I just want to show you that this expression could actually, we could look at it in a couple different ways. And so what I want to point out here is that in this first meal, this is a hamburger meal, I have 3 meals. I have 3 hamburger meals. But what that means is that I have 3 hamburgers. When I check my bag, I should have 3 hamburgers. I should have 3 fries. And I should have 3 sodas, right? Because if I have 3 hamburger meals, I should have also 3 of each item. Same over here. If I have 1 chicken meal, so I should also have 1 chicken, 1 fry, and 1 soda for whoever ordered this chicken meal. And then I should just have a chicken and a fry left over. But I want to point out this idea here that a meal consists of, if I have 3 meals, like I do with the burgers, that means that I should have 3 hamburgers, 3 fries, and 3 sodas. with those 3 meals. And so that brings us to the idea we're going to be talking about today, which is the distributive property. So once again, I'm going to just let you sit with the actual total. I'm not so concerned about that right now, but hopefully you were able to figure out what the total would be here. And maybe there's some more questions that came up as you were trying to figure that out. Maybe you got something different than me or thought about it differently. So we're going to talk about the distributive property. The distributive property states that if I have a number, and this looks like the hamburger meal thing I just did, if we have A times B plus C or B minus C, that's a plus or minus sign, it means it could be either, then what we can do is we can distribute this number to within the parentheses. So what that equals is A times B plus or minus, depending on what was on the inside, A times C. Whoops. So if I have 3 hamburger meals, that means I should have 3 of this and 3 of that. Okay, it's the idea I just talked about up here. And here's a little picture to illustrate it. If I have 3, so let's take a look at this here. I've got 2 plus 4, okay? But I have 3 of those. So I have another 2 plus 4 and another 2 plus 4. So I can rewrite that as that I have 3 2s plus 3 4s. So this might seem a little silly, like why are we doing this? Why does it matter? Well, it can help us to simplify an expression further and to get closer to a final answer, a more simplified answer. So this idea of distributing, as you might see when I'm drawing these little arrows, what it means that I'm dealing out or I'm passing out shares of something. So if I were going to distribute a ticket to each student, I would be passing out a ticket to each student. I'd be passing it out to every single student in my class. So that's what distribute means, is to deal out or to pass out shares of something. And so that's what we're doing here. So here we're just going to walk through a couple examples and we'll be finished. So we're going to use the distributive property to rewrite each expression. And then we're going to simplify completely. So the distributive property, I hope that you've heard that word before and I hope that you've seen this used. Hopefully this is review, but this is also something that can get a little tricky. So make sure you're following along with me, especially as we're just reviewing this idea today on the guided notes. So in this first one, I have 2 times 3a minus 2b plus c. So there's nothing I can do if we're using order of operations looking inside the parentheses. Whoops. If I'm looking inside these parentheses, there's nothing that can be simplified. I've got 3a's minus 2b's plus c. There's no like terms. Nothing can be combined. But we're going to use the distributive property to simplify this further because this 2 actually can be passed out to each of these terms on the inside. We can actually get rid of this 2. We can pass it out because it means what this is saying is that I have 2, let me go back. I have 2 times, meaning I have 2 of these things. I have 2, 3a minus 2b plus c's. I have 2 groups of that. So what that means is if I pass this out, it means I should have 2 3a's. I should have 2 negative 2b's, and I should also have 2 c's. So that's the process I'm going to follow. So if I have 2 3a's, what I do is I multiply these coefficients. 2 times 3 gives me 6. So if you want to put a little note, what we're doing when we distribute is we're multiplying. So 2 times 3 is 6, and then you keep the a. Then I go to the next one. 2 times, be careful here, this is a negative 2. 2 times negative 2 is negative 4, and then you keep the b. Finally, I have 2 times c. This is like a secret 1, so 2 times 1 is a positive 2, and then you keep the c. So once again, I've got a's, b's, and c's. Nothing can be combined, but I did get rid of the 2 out in front, so I did simplify this a little further than it was before. So this would be my final answer. Notice that I didn't solve it. I don't have, a equals 2, but I did simplify it as far as I could. Looking at the next one, I have 12 times 6 minus half x. So once again, if I look, you always want to check on the inside. Can I simplify the inside? Well, no, I've got a plain 6 minus 1/2 x. I don't have like terms. So to simplify this expression, I do notice that I have a number out here. I have 12 of these things. So that means I have 12 of these and 12 of these. So I'm going to use the distributive property. I'm going to pass out that 12 to everything inside the parentheses. What that means is I'm multiplying. So I have 12 times 6. Notice that 6 has no variable, so we're just straight multiplying. 12 times 6 is 72. And then I have 12 times, be careful here, negative 1/2. When you're multiplying by a fraction, you're actually dividing. So if you don't believe me, plug that in your calculator. But 12 times negative 1/2 means I'm actually doing 12 divided by negative 2, which is negative 6. Use your calculator to help you there. And then I do have an x, so minus 6x. So I have 72 minus 6x. There are no like terms, so this is the final answer. Okay, on this last one, I have a negative 2 out in front. I have negative 2 of this. So what that means is I'm going to pass out a negative 2 of these, negative 2 of these, and negative 2 of those. And when I'm passing out, I'm using multiplication. So I have negative 2 times 3x squared. Oh, first I should check. 3x squared plus 5x plus 1, there are no like terms. I can't simplify the inside. Always check that first. So negative 2 times 3, that's negative 6. Keep the x squared. Moving on, I have negative 2 times 5, that's negative 10. Keep the x. And then I have negative 2 times 1, that's negative 2. Once again, I've got an x squared, an x, and a plain 2. There's nothing more I can do, and this is the final answer.